All right, doing this problem called design, add, and search words data structure. Okay, let's have a read. Design a data structure that supports adding new words and finding if a string matches any previously added string. Okay, so implement the word dictionary class. Word dictionary initializes the object. Add word adds the word to the data structure. It can be matched later. And search word returns true if there is any string in the data structure that matches word or false otherwise. Word may contain dot where dots can be matched with any letter. Okay, it seems like you would add this word dictionary, you'd add this as like maybe a trie or something, right? Uh, if there is any word, and then this, I think this is the tricky bit. So search word returns true if there is any string in the data structure that matches the word or false otherwise. Word may contain dots where dots can be matched with any letter. Okay, let's look at an example. So add word, add word, add word. Okay, let's look at this. So you added this word bad, dad, mad, and then you are searching for pad, doesn't exist, bad, doesn't exist, and then dot ad. So for dot ad, you use any dot and then you try. Okay. Interesting. So let's make use of a trie data structure to save, and then when we do the search, we sort of modify the way that we search. Does that sound fair? Sure. Okay, so let's first try the uh, what are the different characters that it can consist of the dictionary? Uh, word in search consist of dot or lowercase. Words in add word consist of lowercase. Okay, so dictionary only has lowercase English characters. Okay, so we have okay everything. Let's do inside this only. So let's have a class called try node where we have a boolean and of word and we have a try node array. Let's call it next of size 26. Word dictionary, if you're initializing, you would do something like so let's have a root. So try node root equals to null, and we will do root equals to new try node. How about that? When you're adding a word, let's add the word into the try. So for each char c in word dot to char array, uh, if if node dot next of c minus a, if this is null, then you would want to insert it. So node dot next of c minus a is no try node, and then you would do node equals to node dot next of c, right? And at the end, you would do node dot and of word equals to true. This is how you add the word. Now real bit is searching the word. So while searching the word, the tricky stuff is you have to match dots with anything, right? So let's start try node node equals to root, and then let's go for each char c in this. We're gonna do so. There are two cases. If c is if c is not equals to dot, which is quite easy, right? And there is an else case. Handle the else case later, maybe. So if c is not equal to that means c is a then it's just if uh, node dot next of c minus a is equals to null, then there is a problem. Just return false, and else you do node equals to node dot next of c minus a, and this else we don't know what to do with this else, but outside the end you just want to return probably for a return. Now this else part is a tricky bit, where if this is a dot, then if there is any non-null node, uh, that will work. So now I have to try all. One by one, I have to just try all, right? Which is where I want to see how to now. Can I call it recursively or something with the index and the node? Um, okay, let's see how we can optimize it. Essentially, what I want to do is here I want to do for each node. So for int I equals to 0, I is less than 26, I plus plus. If node dot next of I is not equals to null, I'm gonna try this, right? And the way that I'm going to try this is, yeah, I feel like I wanna do it in a recursive manner. Makes sense. So let's try and do it in a recursive. Let's try to write a recursive function that can handle few things. So this is probably function find, like, so let's add a private boolean search where I'm searching word. I am at a specific index in the word. I am also at a specific trie node. I can call it root, right? These are the things. And now what I'm going to do is if index equals to word dot length, then I want to do return root dot end of word. Fair enough, makes sense. If you complete the word, then you want to ensure that the last one that you're on is an end of word, right? Let's call it, yeah, root is fine. I want to call it node though. Okay, so try node, and we can say node dot end of word. Otherwise, you want to check if node is null, then there is a problem already, right? And not just that, if that should never be the case, but okay. If let's get the char. So char c equals to char c equals to word dot char at index. Now, if a node dot so first you want to check whether c is, if c is equals to if c is not equal to dot, then it's easy, right? If c is not equals to dot, then it's just if then you can simply do like you do search, you do word index and you can do sorry, index plus one, and you could do node dot next of c minus this, right? And now it is possible to be null, and if it is null, it will return false from here, right? All great. Else you want to try all of them. So else you're gonna do for I equals to 0, I is less than 26, I plus plus. If search word index plus 1 node dot next of I, if anything works, you return true. If nothing works, you return false, right? So that's my idea. And now I remove the code from here, and you just do return search word index 0 and try node as root. All right, let's see if this makes sense. Let's run. Runtime error, cannot read field and of word because parameter 3 is null. Okay, let's see where this error is coming. It's coming in the search. Isn't end of word boolean? It is. So is it some issue? Control Z. Okay, let's run again and see if there's a problem. Because parameter 3, okay, it says node is null. Huh. And yes, node can be null. Let me try and make sense of this. When can that? But essentially, if node is null, then uh, you should be returning false first, and then you go here. Yeah, this is fair. Correct. Okay, run. All right, submit, and it works. All right.